In current electricity, though effect of the current electricity is important, but from the topic of current electricity, we see very few questions in JEE. Last year in 2015, there were only 2 questions, but 2014, 13, 12, 11, the questions were 1. And in 2010 there were again 2. So we find either there will be 1 or 2 numericals in JEE. We should be prepared that there should be 2. So accordingly we can give weightage to it. Now we come to the numericals. First numerical, please see here. All you know, this is related to Kirchhoff law. So we will solve it here. See the batteries, 9 volt, 6 volt. You may have your own methods, whatever is taught by your teachers. You can go for any method, for any type of equations. I will go according to, I give the lessons. So from 9 volt there will be 1 current, and let's call this current I1. This I1, this is the branch which starts from here. So here also this is I1. This current is again I1 up to this. I will give them the name AB, CD and EF. Okay. So D, F, E, C. This is one branch, current is I1. Now from here I take the current I2. So the range of I2 starts from previous junction and goes to the next junction. So this complete branch is I2. So here it is I2 up to this. Now we come here. This is I1 entering the junction, and this is I2 leaving the junction. So here this current I will take it from C to D. This will be I1 minus I2. I1 minus I2 goes here, I2 goes here. Okay. This I1 minus I2 reach here, I2 combine, and again it become I1. So this is distribution is complete. Distribution of current. Now we go to the loop law, and we have to take loops one by one. So loop A, B, D, C. A, B, D, C. This is I2 into 3 ohm. 3 I2. Here it is in opposite direction, minus 1 into I1 minus I2. I1 minus I2. Again go here. Voltage across this, from this point to this point, the potential difference is 6 volt, but this is at a lower voltage, this is at a higher voltage. So voltage from A to B is minus 6 volt. This is lower, this is higher. So lower voltage minus higher voltage is minus 6 volt. Minus 6 volt. So this is equal to 0. So I simplify it. This is 3I2 minus I1 plus I2 is equal to 6. And this gives 3I2 plus I2, that is 4I2. 4I2 minus I1 is equal to 6. Okay, this is equation 1. Let's go for equation 2 and we take another loop. Let's take this loop. The name of this loop is CDFE. Here it is I1 minus I2 in this direction, so plus I1 minus I2 multiplied by 1, then 3 multiplied by I1, 3 I1, here minus 9 volt, minus 9, and here again plus 2 I1, plus 2 I1 is equal to 0. So this is I1 plus 3 I1 plus 2 I1. 3 and 2, 5 and 1, 6 I1 minus I2 and no other I2. Minus I2 is equal to minus 9 goes here, 9. This is equation number 2. So it's very simple, and now it's a mathematics of two unknown quantities I1 and I2. 6 I1 minus I2 is equal to 9. Okay, let's multiply this with 4 and solve it. Here it is 4I2 minus I1. 6. (42 upon 23). In CD, current I1 minus I2 is 42 upon 23 minus 45 upon 23. This is equal to minus 3 upon 23. Minus 3 upon 23 is equal to 0.13. Negative. The negative sign here shows what? Negative sign means I have taken this direction as positive sign, but the answer has come to negative. That means actual direction of current is from D to C. So we have IE 0.13 from D to C. So from D to C or you can say, sorry, I should have taken it PQ. So is it from P to Q or Q to P? The answer is from Q to P. So this is the right option. Okay, let me see the question. Yes, PQ. It is like that. This is P, this is Q. So if I take it PQ, this I have taken as C, D. Okay. So my answer is with minus. Minus means the actual direction of current is opposite to this, Q to P. So I have taken this Q to P, 0.13 ampere. This is how we make it, and it's a very basic question of Kirchhoff law. You are also getting it in CBSE examinations, so it's quite easy one. Okay, let's go to the next one. Okay, here is the next question. When 5 volt potential difference is applied across a wire of length 0.1 meter, the drift speed of electron is this much, electron density this much, the resistivity of material is close to this. Okay, what we are supposed to find out? We are supposed to find out resistivity. What is given to us? Length of wire 0.1 meter. The voltage across V is equal to 5 volt. Drift speed of electron is 2.5 into 10 to the power minus 4. If the electron density, we remember it is small n, 8 into 10 to the power 28. Okay, these are the quantities. Resistivity we have to find. Drift velocity and n, that is given to us. What are the relations? Do you remember any formula? What we have to find out is resistivity. So number 1, we must write a formula for resistivity. The resistivity, we know it is R divided by L into A. Is it okay? Yes. Okay. Now, total resistance, is it given? No. Length given? Yes. Area not given. We will start writing here. The resistance is not given to us, but voltage is given to us. We know how voltage is converted into resistance. So in place of resistance we will write voltage upon current, and this is length, this is area. Okay, now again voltage is given to us, length is given to us, area is not given, current is not given. So again we change it, current, and drift velocity is given to us. So we take the hint, current is to be converted to drift velocity. So we will write it voltage V, current is equal to N, E, A, and drift velocity. This formula you all remember. NEAVD, and this is length into area. So here area is cancelled. Now voltage is given, N is given, E we have in knowledge, drift velocity is given, L is given. Put the values and you get it. Okay, let's put the values. Voltage is 5 upon N. N is given to us. Electron density 8 into 10 to the power 28. 8 into 10 to the power 28 into 1.6 10 to the power minus 19 into drift velocity is given to us. Drift velocity is this 2.5 into 10 to the power minus 4 into length. Length is again given to us 0.1. Here it is voltage only. So we will do these calculations and do all these calculations, and you will find out the answer, and after doing the calculation it comes out to be 1.6 into 10 to the power minus 5 and ohm meter. After doing all the cancellation you will find it, and here we will see where it is. So 1.6 into 10 to the power minus 5 ohm meter. This is the right option. Okay, now let's come to the next question. It was a very simple one. You have done it this type of questions. The next question now we take is, okay, there are 15 bulbs, each of 40 watt, other this, 5 fan this, heater this, operated by a voltage source of 220 volt in one house. Then rating of the fuse should be this. It is asking for our knowledge whether we know how the household wiring is done. We have studied it. घर में जितने भी फैन, बल्ब और लोड हैं, सब एक दूसरे के पैरेलल होते हैं. They are parallel to each other. This is household line in different rooms, and from here we get this supply from outside. In this supply, here we fit a fuse. Now this line has got a particular capacity. Capacity means what? Rating. Rating means what? If there is a current higher than a particular current, the heat will be so much that the total wiring of the house will burn out. So we must keep the current less than that. So what we do? We put a fuse in series with the house wiring, so that when that current start flowing in it, the high current, this fuse will blow out first. What are the properties of a fuse? It should have a low melting point and it should have a high resistance. Due to resistance it will get heated up, and due to low melting point it will melt. When it melts, then the circuit is broken and there is no more current in this, and this wiring is saved. That is the purpose of fuse. Anyway, that is not asked. What is asked? What should be the rating of the fuse? How we decide the rating of the fuse? We calculate how much current is required in the circuit, and our fuse will be slightly more than the current required. Not very high. If it is very high, it will allow very high current, and then the complete circuit will burn out. So then how load is connected? See how load is connected. There are 15 bulbs, each of 40 watt. This is say plus minus. So from here these are 15 bulbs, 40 watt. How much will be the total load? 40 watt, 15 bulbs will be the load here. Then 5 bulbs, 100 watt, plus from here, minus from here, and here are separate like this. Each bulb will get a total supply of how much? 220 volt. This is 220 volt. So you see, this bulb gets 220, this bulb gets 220, this bulb, every bulb will get 220 between minus and plus. In this way, all these are fitted in parallel. So these are what? 5 bulb, 100 watt. 100 watt, 5 bulb. After that, 5 fan, 80 watt. Here we have 5 fan, 80 watt. 80 watt, 5 fans. 1, 2, 3, 4, 5. This we are making schematic diagram just to calculate the load. घर के कमरे ऐसे नहीं हैं. Okay, it is simply diagram for the load. Then we have one heater of 1 kilowatt. Here we have one heater, and this is 1 kilowatt, that is 1000 watt, and this is only 1. Okay, other things are not given. So now you see, this is the circuit of the household, and every instrument is connected across 220 volt. Is it a parallel or series connection? Doesn't matter to us for calculating the load. Anyway, if it is asked, is it parallel or series, what will you reply? It is parallel. How much is the load? How much is the load? Calculate load of each instrument, add it up, that's all. Don't try to find out net resistance. It's a very long method. Don't go for that. Okay. सबका load गिनते जाइए. Okay, now let's make the summary of the total energy used. Energy per second is watt, power. So for the 15 bulbs, 40 watt. 40 into 15, 600. After that, 5 bulbs, 100 watt. 100 watt, 5 bulbs. After that, 5 fan, 80 watt. 80 watt, 5 fan, 400. 1 kilowatt, 1 heater. Kilowatt is 1000 watt. 1 heater is equal to 1000. How much is the total power required? Whether they are in parallel, everything when they are in parallel, they use their full power according to the rated voltage. If they are connected to the rated voltage, they will use full power. So all of them are using this full power. So how much is the total power required? Add it up. This will be 2500 watt. Okay. Now we know the formula for power. Power is voltage into current, or current is equal to power upon voltage. Power is 2500 and voltage is 220. That is given to us. So this is the current comes to be 11.3 something or 11.4 ampere maximum. Now that is the current here, and when this current is flowing, then the current should continue. The circuit should not be broken. When it should be broken? The answer is when there is some fault and current goes beyond this. Now we will see the fuse which will just close to 11.3. A little higher than 11.3, so that current is permitted, but if current rise, it should fuse. So if fuse is 10 ampere, with 11.3 it will blow, with 12 ampere it will not blow, 14 ampere will not blow, 8 ampere will blow up. So which is the nearest one? 12 ampere. It should be higher but nearest. So this is our right answer, 12 ampere. So this is how it is done. It's a very simple question. You might have done it in class 10th also. Okay. So, but it's very practical thing. In our household use, we have to use it. We go to the next question now. Read the question. Try to imagine the circuit. Okay, now what do you understand by rating? Rating of a bulb means if we give 220 volt here, it will give us a power of 25 watt. But if we don't give it 220 volt, it will not give 25 watt. Okay, if we give less or more, then what will happen? The answer is, if we give it less voltage, the current will be less, and therefore the power, which is I square R or V square upon R, that will also be less. Voltage 220 वोल्ट रेटेड वोल्टेज है, अगर उससे कम वोल्टेज देंगे तो ये पावर कम देगा, क्योंकि पावर का फॉर्मूला है V स्क्वायर अपॉन R. अगर ज्यादा देंगे तो क्या होगा? What will happen if we give the higher voltage? The answer, the current will be more, the heating I square R will be more than it can bear. Every instrument can bear a particular current because that heating it can radiate. जितनी करंट से हीट बनेगी उतनी हीट को उसको रेडिएट आउट करना है. If it cannot do, then heat will accumulate, its temperature will rise and finally it will melt. वो चीज मेल्ट हो जाएगी जिसको हम कहते हैं बल्ब का फ्यूज होना. इस तरह से अगर हायर वोल्टेज देंगे बल्ब फ्यूज हो जाएगा, लोअर वोल्टेज देंगे थोड़ा कम वोल्टेज दिखाएगा लेकिन फ्यूज नहीं होगा. ओके, नाउ व्हाट इज अवर क्वेश्चन? अवर क्वेश्चन इज बोथ द बल्ब्स विल फ्यूज, वन बल्ब विल फ्यूज, सेकेंड बल्ब विल फ्यूज, नो बल्ब विल फ्यूज. तो मैंने अभी आपको क्या बताया कि फ्यूज क्यों होगा? अगर वोल्टेज ज्यादा मिलेगी. किससे ज्यादा? जितने उसके ऊपर रेटिंग लिखी हुई है उससे ज्यादा. तो यहां पर रेटिंग 220 वोल्ट है, इसकी भी 220 वोल्ट है, इसको हमने 440 वोल्ट लगाया, दोनों आधा आधा बांट लेंगे. 220 नो, आधा आधा नहीं बांटेंगे, बिकॉज बल्ब इज बेसिकली ए रेसिस्टेंस एंड द वोल्टेज विल बी डिस्ट्रीब्यूटेड अकॉर्डिंग टू देयर रेसिस्टेंस. उसमें अगर किसी का वोल्टेज 220 से ज्यादा हो गया तो वो फ्यूज हो जाएगा. सो बेसिकली ये क्वेश्चन में हमारे बहुत सारे नॉलेज के टेस्ट हैं. पहला, वेदर वी नो दैट बल्ब इज ए रेसिस्टेंस. आंसर यस, वी नो बल्ब इज ए रेसिस्टेंस, और उसके कनेक्शन वैसे ही होते हैं जैसे रेसिस्टेंस के कनेक्शन. ठीक है. पावर, वी नो पावर इज V इंटू I, और विद रेसिस्टेंस इट इज V स्क्वायर अपॉन R. ठीक है. नाउ in a bulb when we change a voltage, what does change? Answer, the current change, the power change. In a bulb when we change the voltage, what does not change? क्या चीज नहीं चेंज होती है बल्ब में? आंसर है रेसिस्टेंस चेंज नहीं होता. आप कोई भी वोल्टेज लगाइए उसकी पावर कम हो जाएगी, ज्यादा हो जाएगी, पर क्या चीज नहीं बदलेगी? रेसिस्टेंस, बिकॉज दैट इज हार्डवेयर, दैट इज मटेरियल इन दैट. और वो मटेरियल हमारी वोल्टेज बदलने से मटेरियल तो नहीं बदलेगा, सो रेसिस्टेंस विल नेवर चेंज. सो इट हैज गॉट रेसिस्टेंस R1, इट हैज गॉट रेसिस्टेंस R2. How much is R1 and R2? We can very well calculate it. R1 is equal to, we know the formula, P is equal to V square upon R. Okay, you know both the formulas, I square into R, V square upon R. So with V its relation is V square upon R. So for first, R1 is equal to V square upon P. From where we have to take the V, the rated voltage. किसी भी बल्ब का रेसिस्टेंस निकालने के लिए अप्लाइड वोल्टेज मत यूज करिए. फिर से, बल्ब का रेसिस्टेंस निकालने के लिए अप्लाइड वोल्टेज यूज नहीं करनी है. उसके ऊपर जो okay, this is the resistance. Now R2, again V square divided by power. Power 100. Okay, these are the two resistances, 1936 and 484. Now you understand how the voltage will be divided in it. The answer is voltage across. We know that current flowing is same in it. So I into R1 is V1. I into R2 is V2, divide the two. So this is R1 upon R2 is equal to V1 upon V2. This is V1 upon 440 minus V1. So we get it here, R1 upon R2. R1 upon R2. Put the values, 1936 upon 484 is equal to V1 upon 440 minus V1. Okay, now this leads to this, we can cancel. See, it is a multiplication of 4. Yes. So this is 4 to 1. Now we can multiply this. V1 is 352 volt and here it is distributed. If this is 352 volt, then rest will be here. V1 will be 352 and this minus 352, that is 88 volt. This is V2. V1 352 volt. Now see the conditions in both. What we discussed earlier, if voltage applied is less than the rated voltage, voltage applied is less than the rated voltage, the power will become less but it will not fuse. If the voltage applied is more than the rated voltage, the current will be so high, it will get heated up and it will fuse. तो जैसे ही हम इसको switch on करेंगे, this voltage will be 352 distributed, which is much higher than the rated voltage, and this 25 watt will fuse. Okay, दूसरे का क्या होगा? The moment it is fused, the circuit is broken and it will not fuse. So, do we have any answer? 25 watt bulb will fuse. This is the right option. Both the bulb will fuse. This will never happen because the moment one fuse, circuit is broken. दूसरा बच जाएगा हमेशा. Okay, so our answer is 25 will fuse. No bulb will fuse is also not correct. At higher voltage, it will not stick. It will fuse off. Okay, let's go to the next question now. See this question and read it. रेसिस्टेंस ऑफ लीड वायर इज 6 ओम. ये जो पूरी लीड वायर कमरे की है उसके लिए मैं यहां लिख लेता हूं 6 ओम. इट रिप्रेजेंट द रेसिस्टेंस ऑफ कंप्लीट वायर. ओके, वन बल्ब ऑफ 60 वॉट इज केप्ट ऑन इन दिस रूम. दिस इज a 60 watt bulb. ओके, इनिशियली सिर्फ ये बल्ब जल रहा है. ये 120 वोल्ट सप्लाई है. द करंट गोज फ्रॉम हियर, इट कम्स फ्रॉम हियर. दैट्स ऑल. सेकेंड, तो जब ऐसे करंट फ्लो हो रही है, देयर इज सम पोटेंशियल डिफरेंस अक्रॉस दिस. इसको कुछ ना कुछ पोटेंशियल डिफरेंस मिल रहा होगा. ठीक है, अब हमने इसको स्विच ऑन किया. स्विच ऑन करने से ये करंट यहां भी जाती है, यहां भी जाती है, दोनों में जाती है. तो क्या इसकी वोल्टेज सेम रहेगी या गिर जाएगी? वी विल फाइंड आउट. पर आप याद रखिए ये वोल्टेज ड्रॉप हो जाएगी. ओके, इन्होंने यही पूछा है कि ये ड्रॉप होगी, कितनी ड्रॉप होगी. तो हमको ड्रॉप निकालने के लिए दो वोल्टेज निकालनी पड़ेगी. What was the original voltage and what is the voltage after switching on the heater? Heater on करने के बाद voltage कितनी हो गई? What is the difference? How much will be the decrease? Okay, so पहले initial voltage निकालते हैं. कैसे निकालेंगे voltage? फॉर्मूला जो हमने पिछले क्वेश्चन में यूज किया था सेम यूज करना है. When it is off, then there is only this 60 watt. How much is 60 watt bulb? Supply voltage in one room is 120. Resistance of one wire is 6 ohm. One bulb of 60 watt इसकी रेटेड वोल्टेज नहीं दी है, वी अंडरस्टैंड द रेटेड वोल्टेज इज दिस वोल्टेज सप्लाइड 120 वोल्ट। तो इसका रेसिस्टेंस कितना होगा? रेसिस्टेंस फॉर बल्ब इज इक्वल टू, व्हाट इज द फॉर्मूला फॉर रेसिस्टेंस? दैट इज V स्क्वायर अपॉन P, पावर। कंफ्यूज मत होइए, ये 60 वॉट है, 240 रेसिस्टेंस है। इसका 60 रेसिस्टेंस है, इसका 240 पावर है। ठीक है, तो हमने देखा जिसकी पावर ज्यादा उसका रेसिस्टेंस कम, वी ऑल नो दैट। ओके, तो पहले इसके अक्रॉस कितनी वोल्टेज थी? हाउ टू फाइंड इट? We will make this circuit here. See, 6 ohm, and this is 240 ohm. This is 120 volt. How much is the voltage here? Okay, 6I plus 240I. I 6 and 240, 246I is equal to 120 volt. Therefore, how much is the voltage here? Here voltage is 240 into I. Therefore, 240I is equal to 12 into 240 divided by 246. No, it is not, it is 120. Okay. $240 plus 6. 246 into I is 120. So 240 into I is 120 into 240 divided by 246. Solve it, 117.7 volt. Okay, so the voltage across bulb, this is voltage across bulb in case 1 is equal to 117.7. आप देखिए कैलकुलेट करके कितना आता है. इज इट कमिंग सेम? ओके 07. Okay, I will correct it. This is 07. This is the voltage across bulb in the first case. Now we come to the second case. Second case कब होगा? जब हम इसको switch on करेंगे. When we switch on the heater, then what will happen? Then the circuit will be like this. See, 6 240, 60 and 120. So we have to find out what is voltage here. Now 240 and 60, they are parallel to each other. If they are parallel to each other, then what will be the total resistance? Total resistance will be 60 into 240, 60, 240, 60, correct? 60 into 240 divided by 60 plus 240, 300. This is 48 ohm together. So now it is be 120 volt, 6 ohm, 6, 240 and 60 in parallel. This has come to 48. 48 ओम. हमको कहाँ की वोल्टेज चाहिए? हमको इसकी वोल्टेज चाहिए. व्हाट इज द V अक्रॉस दिस? यानी 48 के अक्रॉस कितनी वोल्टेज है? दिस वोल्टेज वी वांट टू नो. This is one branch, the current flowing is I. So what is the voltage here? 6I. What is the voltage here? 48I. How much is the total? 54I. 54I voltage is equal to 120 volt. I will write it here. 54I is equal to 120 volt. Therefore 48I is equal to 120 into 48 divided by 54. Okay. 6 8s are 6 9. This is again 3 3 3s are 9, 40. 320 upon 3. This is 106.67 volt. So now the voltage across this will be 106.67. This 106.6 is across both. इसको भी उतनी वोल्टेज मिलेगी, इसको भी उतनी ही मिलेगी. पहले कितनी मिल रही थी? पहले हमने निकाली 117 मिल रही थी. So what is the decrease? Decrease 117.7 minus 106.67. So this is 17 minus 6, 9 point something. Do we have any answer? A, B, C, D. So the answer which is very close, sorry, not 9, 17 minus 6, it is already 10 point something. Okay, so this is the nearest answer, 10.04. अब आप और करेक्टली करेंगे, you will find out. Yes. This was not 7. Oh, sorry. This was 07. 07. And now you see it comes to 10.4. Whatever it is. So if it is 10, we know this is the right answer. This gives us a principle. अगर बल्ब के पैरेलल में कोई दूसरा हीटर लगेगा, जब भी वो स्टार्ट होगा तो बल्ब के अक्रॉस वोल्टेज कम हो जाएगी and it will show a dip. right? Meter, current in the primary circuit is 0.2 ampere, specific resistance of wire is so much, cross section area is so much, potential gradient across the wire must be this. What we have to find out is potential gradient. Potential gradient का फॉर्मूला क्या होता है? Just remember potential gradient. Potential gradient for a potentiometer is potential drop divided by total length. Potential drop per unit length is potential gradient. Okay, now we have to find out these quantities from here. So potential, is it given to us? We will try to convert this quantity into the given quantities. Okay, let's do it. Voltage is current into resistance. Current into resistance. Current I, is it given? Yes. So we will keep it I. Resistance not given. तो resistance का formula लिखेंगे, that is rho L upon A. Resistance, and this L is here. So I into rho into L, L A. L is cancelled. I rho into A. Rho. What is that? Resistivity, specific resistance given. I given. A, area of cross section. It is given. If these three things are given, you can find it. तो इसमें कैच कहाँ है? इसमें कैच है that if we know the formulas of potential gradient, resistance in terms of resistivity, we can make it. हमें पोटेंशियल ग्रेडियंट निकालना है V अपॉन L, और हम यहाँ देख रहे हैं हमको क्या क्या दिया गया है? स्पेसिफिक रेसिस्टेंस, करंट एंड एरिया ऑफ क्रॉस सेक्शन. सो वी ट्राई टू कन्वर्ट. वोल्टेज नहीं चाहिए, वी कन्वर्ट इट इनटू I इंटू R. क्यों? क्योंकि I दिया है. सो वी हैव कन्वर्टेड इनटू I इंटू R. R हमको नहीं दिया है पर स्पेसिफिक रेसिस्टेंस दिया है, सो इट इज स्पेसिफिक रेसिस्टेंस इनटू L अपॉन A, एंड वी नो L इज नॉट गिवन. L कैंसिल हो गया, वी गेट इट दिस वे. तो आपको जितने एडजस्टमेंट करने हैं पहले उसको अलजेब्रिक फॉर्मूला में ही कर लीजिए, सो दैट इट बिकम्स वेरी इजी व्हेन यू पुट द वैल्यू. अलग अलग चीज की वैल्यू निकालने की कोशिश मत करिए. सॉल्व इट, कैंसल इट, जितना आप कर सकते हैं ऐसा ही कर लीजिए. एंड नाउ यू फाइंड इट्स वेरी इजी. आई की वैल्यू हमने यहाँ रख दी 0.2, देन रो की वैल्यू रख दी 4 इंटू 10 टू द पावर -7, और उसके बाद a की वैल्यू यहाँ पे रखी. दिस a इज 8 इंटू 10 टू द पावर -7. All are in SI values, so we'll put it like this. 0.1, and what is its unit? Volt per meter. .1 volt per meter. यहाँ पर है क्या? Yes, here it is 0.1 volt per meter. So this is our right option for it. Okay, let's go to the next question now. Hmm. 400 ohm resistance is obtained from 4 resistances, each of value 100 plus 5%. We have 4 resistance and we have to make 1 resistance out of it. So these are the 4 resistances. We know how to make 400 ohm from 100 ohm each. We have to put them in series. Okay, so okay, this will become 400. But the question is, how much is tolerance? Because each of them is not exactly 100. It is 100 plus minus 5%. So the first one may be minimum 95, minimum 95, and how much it will be maximum? 105. Second one will be like this. Third one again like this, and fourth one also like this. What is the probable minimum value? Probable minimum value. This is 380. What is the probable maximum value? 420. What is the mean value? 4 in series. Mean value is 400. How much is the tolerance? It can decrease by 20. It can increase by 20. So how much is tolerance? Tolerance is deviation divided by mean value into 100. So this deviation is 20. Plus 20 minus 20. Mean value is 400. 400 into, make it percentage, multiplied by 100. So this is equal to 5% plus minus. तो देखिए, एरर में हमको क्या नियम याद था? If we add the quantities, the errors will be added. The errors will be multiplied. यहाँ कुछ नहीं हुआ, because our total value has also increased. So what will be our answer here? This is the appropriate answer, and this is how we can conclude it. देख लीजिए, अगर सबकी मिनिमम वैल्यू लेते हैं, इससे कम तो हो ही नहीं सकता, इससे ज्यादा भी हो ही नहीं सकता. तो मीन वैल्यू से डेविएशन है कितना? आइदर +20 और -20. तो +20 -20, 400 में डेविएशन है, तो 100 में कितना होगा? 5%. So this is the deviation. We have done it.